Today we're going to look at the graph of the sine function. Now up until this point we've been thinking of sine as the y values on the unit circle. And that's what sine is. However, there is a different way to look at sine. Today we want to look at sine as a function that's graphed on a traditional xy axis, where the horizontal axis, the x-axis, will be the angle measure, and the vertical axis will be the actual value of sine. So here we have a unit circle, and of course you can see the values for sine. There's the 1/2, the square root of 2 over 2 as we go around the circle, the square root of 3 over 2, 1, and so forth. But what we want to do is we want to see if we can translate that information onto a horizontal and vertical axis. So we'll start off taking the angle measures, and I'm going to just go in multiples of pi over 6, 30 degrees, just for simplicity's sake. So we're going to start with 0, and of course the value of sine at 0, we'll find out in a minute, of course is 0. Now we've got pi over 6. I'll put that on the axis, pi over 3, and so forth. We'll go around the circle. Every multiple of pi over 6, and we'll place that on this horizontal axis. All the way to 2 pi. So what we've done is we've taken these angles on one trip around the unit circle, and I've placed them on this horizontal axis. Now what I want to do is take the sine function values and translate those to the to indicate the height of the sine graph. So first of all, we start off with the first function, which is the first value, the sine of pi over 6. Now recall that's 1/2. So I just take the height and put it corresponding to the angle of pi over 6. Next I take the height of pi over 3, and notice that its height is the square root of 3 over 2, and I send that down here. So what we have here is we have a graph forming. We start to get an idea about, well, what would the function sine look like if it were graphed on an xy axis like this? So I continue on. I next go to pi over 2, and notice here we have the height. Just measuring the height. We got 2 pi over 3. Next is 5 pi over 6. And then pi. And notice pi is 0, so it's just going to be on the axis. Now, notice this. We're at the point now where when I measure the height here, it's below the axis. So I'm going to put that below the axis over here, because that is, sine is negative there. Notice that the sine of 7 pi over 6 is negative 1/2, so that would be a negative. That would be indicated by being below the x-axis. Then I've got 4 pi over 3, 3 pi over 2, and notice the symmetry here. Okay? And then finally 2 pi, which is 0. Now, what we have here is just sort of a framework about what the sine graph would look like. And you can see a pattern forming here. So let's see if we can look at now I'm just going to connect these with a curve, and we'll get an idea about what sine looks like. And there it is. Now oftentimes you'll see the graph of sine, this sine wave, and you'll wonder, well, what is that? I don't see how that relates to the unit circle. Well, now you can see how it relates. Notice, and we'll make these observations more in the future, but you notice that the maximum height here is pi over 2. The minimum is 3 pi over 2. Now, let's look at this graph and just take note of some characteristics of it. First of all, the period of this graph. Notice from the very beginning of the graph where it starts its cycle to the end, we go from 0 to pi to 2 pi. We say, well, that's the period. And you can relate that back to the unit circle. One trip around the unit circle, 2 pi radians. That's how long it takes for sine to make one complete cycle, because after it goes around the unit circle once, it starts again. And you start seeing coterminal angles from the initial revolution. So for sine to make go through one complete cycle, if we start at 0, we end up at 2 pi. So we say, well, that's the period. The period is how long it takes for sine to make one complete cycle. In other words, to go through all the values that it's going to go through, all the y values. So, see, it goes through -1 all the way up to 1, and then to do that, it takes from 0 to 2 pi. Now, the domain of the sine function is all real numbers, -infinity to infinity. There's no real number that you can plug into the sine function and get something that's undefined. Sine is defined for all real numbers. Now, not all trig functions are like that, we're going to find, but sine is. Now, the range, of course, remember we go between -1 and 1, as you can see with the graph. So the range is -1 to 1. We also have something I'm going to define for you here is the amplitude. The amplitude you can think of as half the distance from the very bottom of the graph to the very top of the graph. That's what the amplitude is. But here you can see, if we just have a basic sine graph oscillating around the x-axis, it's the distance from the x-axis to the top or the x-axis to the bottom. That's what we call the amplitude. So here you can see, and of course, this basic sine graph has an amplitude of 1. Okay. Now, notice that we graphed, our graph was from 0 to 2 pi, because I just wanted you to see one period of the graph. But notice that this top graph, we go from 0 to 4 pi. And notice that that will give you 2 complete revolutions. We start here at 0 and go to 2 pi. Then from 2 pi to 4 pi, you see that we have 2 complete revolutions. And this thing would just go on and on. Sine never stops oscillating. We could do a 6 pi, 8 pi, and so forth. Also, we can show what happens when we go the other direction. In other words, here's 0 to 2 pi on this bottom graph. Well, we can show what happens when you oscillate around the circle, or when you revolve around the circle clockwise. Clockwise, remember, you go from 0 to -2 pi. You're getting the negative angles there. So that's what you see here. And these two graphs were simply to illustrate, yeah, we just looked at one period of sine, but sine really oscillates from -2 pi to 2 pi, -4 pi to 4 pi. It's an endless graph, constantly, periodic, constantly going through its cycle.